and kind of accounts for the development of FHIR Shorthand in some sense, because we were using very undocumented spreadsheets at the time, and it wasn't a very pleasant experience. And with my partner, Chris Moselle, who's in the back of the room. Chris, hi. We started thinking about better ways to do things. And Chris had just been working with the development of clinical quality language, which is a domain-specific language for defining cohorts and doing quality measures. And we thought, gee, if only we could just say what we want when we want to do profiles. And I don't know where the first conversation took place, but we started playing with some language constructs around profiling, which eventually evolved into FHIR Shorthand, which was a project that we started in 2019. And then we had our first release early in 2020. So the whole effort of FHIR Shorthand is only dated back like a couple of years, 2 years, a little bit more than that. And it's been a delight to see the community embrace this. And I'll spend this hour or 45 minutes talking about why you might be interested in using FHIR Shorthand, and also just running through some of the basics so that you can use FHIR Shorthand. And immediately thereafter, there's a 10-minute break, and then my colleague Chris will take the floor and we'll do some hands-on exercises. So you'll have about an hour and a half to 2 hours using FHIR Shorthand, and hopefully by the time you go, you'll have a good understanding of what it's for and how to use it. All right, so that's what I've just been through. So I think if you've been to other talks today, you've probably seen something similar to this, that FHIR is a platform or a framework for doing interoperable applications. It provides things like a standard API, the resources that we build off of, and a mechanism to extend and to constrain those resources. But that's not enough. You need to have something else which considers specific use cases. And this is what we call implementation guides. And a typical IG will talk about your use case, explain the problem, talk about the actors and the workflows, terminology that you're using, and value sets that you're binding to your resources. It says what you must, what you may, what you should implement for this use case, and specific API operations. And so I don't know whether the yellow and the blue are in right proportions, and I suppose that depends on the problem at hand. But I kind of think like that's a really important thing, and I shaded maybe 2/3 of that circle saying that's what you need to do with implementation guides. Shows my personal bias. So what is FHIR Shorthand? Well, it's a language that has syntax, and it's used for defining FHIR artifacts of all different types. This includes profiles, but it also extends to instances and value sets and code systems. We even have features for doing logical models, and you can actually do resources. So you can, if you're in a work group and you're in charge of developing some resources, you can use FHIR Shorthand for that. And that's a new feature that we just introduced, several months ago. Typically, you use it for implementation guides, but you can use FHIR Shorthand for creating instances, examples, test cases, or whatever. So it doesn't have to be an implementation guide. It's just for creating any kind of FHIR artifacts. And we'll talk about Sushi, and Sushi is a compiler. Basically, we think about it as slicing and dicing the fish to create the FHIR artifact. So you write it in this fish language, then you run Sushi, and Sushi creates the FHIR artifacts. And we're going to do a little bit of interaction with fish today, the fish language. But generally, when you're doing it at scale, you're going to have a directory with fishfiles.fsh extension, and you're going to run it from you're going to run sushi from the command line. It'll turn the whole bulk of everything into FHIR artifacts. So what are some advantages of FHIR Shorthand? So we think it's pretty transparent and easy to learn. It's very concise, and it should be intuitive. I'll try and prove that today by just doing some examples and not teaching you the theory, but just showing some examples of here's how you do this and that, and see whether you catch on. It's also just text. It's a language like a computing language that's just text. So if you want to do a global search and replace, that's very, very easy to do in your development environment. So I can't tell you how many times I have felt like cut and paste is my best friend, because when you're dealing with a community that has debates about consensus, and the consensus needle goes from here to there and then back again, you make a lot of changes. And so this kind of refactoring is really important. And to go along with that, you can put FHIR Shorthand under source code control. So you can branch it, you can fork it, you can merge it, and you can work with different people doing different parts of the problem. And you always can go back if you make a mistake to some point in that whole tree. We use GitHub, and that works great. Through the Sushi compiler, we can take your fish and always use best practices in terms of generating the FHIR artifacts. We can also combine it with other profiling approaches. So like if you use FHIR Forge, we can take the FHIR artifacts and move them into FHIR Shorthand, and you can go back and forth. So it's very flexible in that way. Chris will introduce you to a bunch of tools that we've created around the FHIR Shorthand language. We now can say, I think last time I was at DevDays, it was in Washington State in Seattle, and we were just beginning. And I couldn't say we had a large set of users. I can't remember, how many users we had, but it was a small set. Now I can say we have a large set of users from all across the community, and that's great because it helps support. You have mutual support, and you can buddy up with people to learn the language. It's also balloted. We put it through the spec through the HL7 process twice and ended up with a normative specification. There are parts of it which are still STU, standard for trial use, but the bulk of the language is very, very stable, and it's been promised. That promise is sort of ensured by the fact it's a normative language. It's also built into the FHIR publisher, so the FHIR publisher will figure out that you've got some fish files and just take care of it for you, which is great. And you can take an existing IG and you can fishify it using a tool called GoFish. And that'll just take all your profiles, all your artifacts, and turn it into fish language for you. So a lot of good things happening there. And here's sort of the trends in terms of projects and how many people are on Zulip chat. And the projects have grown in the last 2 years from about 40 projects to almost 300 projects. We track that through a tool called Fish Finder, which just goes through known GitHub locations and sees whether there are fish files there. Credit to my colleague Max Masnick for that. You can see how the community has grown in Zulip, and we passed 100,000 downloads of the Sushi software just a couple of months ago. We use it internally at MITRE for all sorts of projects with the US government, which we're involved with. You can see the list of some of the IGs there, but all in all, there's well over 200 IGs that are using FHIR Shorthand, and we really don't know how many of them maybe behind firewalls, or we just haven't found. So it's growing in popularity. So we're going to try and familiarize you at least with some of the language and with Sushi. I don't think we'll have much time with GoFish. I would point you to a site called fishschool.org. And that's where you'll find documentation and you'll find other resources. for learning and working with FHIR Shorthand. We will work with Fish Online. I'll point you to some things, and Chris will as well. And then if you're doing in development at scale, you'll want to use Visual Studio Code, where we've got some neat embedded tools to colorize text and to do language prediction and things like that to help you type and produce fish. All right, so you may want to, as you follow along with this, go to fishschool.org, and I'm going to give you some shortened links. So if I go past this fast, you'll have another chance. But you'll see at this web address, you'll see this screen, and there's two sides to it. One side you type your FHIR Shorthand, the other side you get your FHIR JSON. And we only work with JSON, not XML. And you can actually go both ways. So you could add some FHIR JSON to one side and click the button that goes that way, and you can end up seeing what it looks like in Fish. So, you know, if you've done some things, you can see, oh, I don't know what this feature would look like in Fish. You can just take that and basically that's the Go Fish direction. Go to Fish. All right, so I promised you to teach some fish, and let's learn some fish. All right. So here's a FHIR profile, and that's a complete FHIR profile. It's based on patient. And if you want to follow along, you just can type bit.ly/dd-fish1. Okay, and that'll put you into the Go Fish, where you see this example appearing on the left side of that two-sided playground. But let's break this down and see what it says, okay? So there's three parts. I just want to point out that the double slash is a comment, so you can read those, but it wouldn't be executable. The first is a declaration. It says, I'm making a profile, and the name of this profile is My Patient Profile. Very simple. That's your first statement in Fish. Next two lines are what we call keywords, which are common things that you define in a lot of cases. So we made them, instead of free-form statements, it's just declarative. So the first thing you need to define for a profile is, who's the parent? What are you extending? In this case, we're extending patient. So it's a patient resource. You could also use another profile on patient, so you can extend another profile. So if you had US Core patient, you could base My Patient Profile on US Core patient or any other patient profile. Then a description. In this case, it's very short. And then the third part is a set of rules. So rules, they're the statements at the bottom that begin with the asterisks. And I won't go through these rules yet, but I'll show you 5 types of rules that you should get familiar with, because those are the most common rules that you're going to use in creating profiles. So we'll come back to that, and let me introduce a couple of rules. Oh, I guess I have some things to note. So as you look at this, and if you go to that earlier link, you'll be able to relate this to what's on the screen. But notice that fish items have 3 parts: the declaration, the keywords, and the rules. And the declaration and keywords are just followed by a colon. All the rules begin with an asterisk. One thing you may not have noticed is that paths, for example, name.given, name.family, these are paths into the resource. So there's a name element within patient, and name.given is a path into name itself. So we just separate those with dots. And we mentioned comments are with double slashes, but we also have multiple line comments with /*. That's in a Java style. So now I'll talk about rules. So simple rule, cardinality rule. So it gives the path to an element and then two numbers. The bottom line, the lower cardinality, and then dot dot, and the upper cardinality. And this is just to change the base cardinality. So, you know, if name is 0 star, you might want to change it to name 1 dot dot 2. And this is just how it appears in an IG. So you know, you're probably used to seeing this way. And if you just want to change one bound, you just, you know, the lower bound or the upper bound, it's just one-sided. And if you just, you know, if Sushi is forgiving enough, if one of those bounds is not changed, it won't add it to what's called the differential. So it's just say, oh, you didn't change it, it's okay to have it, and we'll just ignore it. Okay, so that's the first kind of rule. Second kind of rule are flag rules, and these are rules which set some information about an element. So you can set must support or include in summary or modifier element, trial use, normative use, draft. These are flags which sort of just give you more information about a data element. And some examples, like you could take onset date and make it must support and include it in summaries. You can also join them with the word and, so you can say, I want identifier and identifier.system and identifier.value. Those should all be must support. Or you can combine it with a cardinality rule. You could do them all at once. You could say subject is 1.1 or 1.1 must support. And so it's a little bit flexible in terms of combining cardinality and flags. Third type of rule is binding. A binding rule uses a keyword from. So we'll take something that is a bindable element, data element, that has a codable concept or a coding, and we'll just say where that value should come from. So for example, the gender might come from that administrative gender value set, okay? So we give the full path to that value set, and that constraint will be built in. Now, for those of you who know FHIR, there's 4 levels of binding strength. There's required, there's extensible, preferred, and example. And you can state that, it's optional. If you leave it out, Sushi will assume the binding is required. So if you just want it to be extensible, you just put that in parentheses after your binding. So the last one, for example, code from cancer condition VS, that's a value set that's named within Sushi, within FHIR Shorthand, and that's going to be an extensible binding. So that's pretty logical. And then type rules, that sets data types. So you can constrain data types. Often in FHIR, it's quite broad. So you can say, for example, my onset X, that's a value which onset could, in FHIR, you know, FHIR condition, it could be a date time, a date, or a period. You could say onset X, in my case, it's only going to be a date time. Or you could say onset is going to be a date time or a period, leaving date out of the picture. And you can also do this with references. You can say the performer is only a reference to a practitioner, and we just use a reference with some parentheses. Or you could even constrain it to references to other profiles. So we could say, if primary care physician and emergency room physicians are profiles that you've built, you could say my performer has to be one of those 2 types, a reference to those 2 types. Okay, so now we've seen 5 basic types of rules. It'll probably be 80% of what you ever do with FHIR Shorthand. And we can go back to that example of a simple profile and say, all right, well, what were those rules that we quickly went by? So the first rule, name 1.2, is a cardinality rule. It's setting the upper and lower cardinality, the number of repeats that you can have for name. The second rule is a flag rule, where MS is must support. So we're saying that the given name and the family name are must support elements. The third one is a binding rule. It just says that marital status, which isn't bound in the patient profile, in the patient resource, we're now going to bind it to that marital status value set. And since we don't say whether it's required or extensible or preferred, Sushi will assume that that's a required binding. And lastly, we have a type rule. We're saying that deceased, which I believe could be a date or a Boolean in the patient resource, we're saying that's only going to be a Boolean. It's true or false, dead or alive. So that's a type rule. So now you've understood the entire profile in 7 lines. Okay, we've built our first profile. All right, so let's go to a different type of item. Let's say an instance. Let's make it an instance of patient, and we'll see some different features. Now this one looks a lot different actually, but it has some commonality. It starts with a keyword. The keyword here is instance. And then, excuse me, a declaration is instance. And then it has 2 keywords, instance of, which tells you what class or what profile or what resource this is an instance of, and a description. So the description is pretty much, you should include it. We recommend you include it in almost all cases. Then it has a set of equals signs. So you'll see like the path on the left, and then an assignment to some value. And that's what you do in instances. You basically fix values of different elements within your structure. So we're saying this is an active patient. We're saying that the first given name is Jane. The second given, the family name is Doe. The gender is female. The birth date, and so on and so forth, down through the address and the marital status, and the GP is referenced to a specific practitioner. So this is interesting because it has some different things. The declaration and the keyword in this case, instead of profile and parent, is instance and instance of. The new type of rule that we didn't see before is an assignment rule. It's fixing a value inside this instance to a specific value. So it's, we've seen active equals true, gender equals female, birth date is 1165, and so forth. We also see in this example references. So we pointed out the reference to Dr. Certainly. That's assumed to be something you've defined elsewhere under that name. And something important is that codes are always indicated with a hash sign. So that's something that is very, very common that you'll need to internalize is whenever you see a hash sign, what follows is a code. So I think in this example, we're saying the gender or the gender is female. So you see that there. That's a code taken from the required code set associated with the gender element within patient. And there's no code system there because you don't have a choice. So because it's defined, the code system is actually defined within the patient resource, you don't have to specify the code system. Makes a smart assumption. Now, in other cases, you need to specify both the code system and the code. And we provide a shorthand for doing that. And it's simply the code system, the hash sign or pound sign, and then the code. So in this case, we bound to we took a code from that marital status value set. And the way you'd state that is by giving the code system and then the pound sign, and then the code is L for legally separated. It's just a one letter code. So that represents, if you're doing a codable concept, that would be one way to populate the codable concept, if you're familiar with that. It's a coding. And we also had in this example a array. Name is 0 star, so it's an array. And even within name, there's given names, which are 0 star, and that's also an array. So to populate specific array elements, you can use the square brackets. And they start at 0 and go from there. So name bracket 0 dot given bracket 0. That way you're certain you're setting the very first element of the given name and the very first element of name. Now it turns out that if you were paying attention in the profile, we didn't have the 0, right? That's because in a profile you don't specify a specific array element. You'd have to do that through slicing, which is a different story for a different day, and that's a little bit more complicated. But the other thing that we can do is simplify that, and I'll show you a simplified version of that profile, which uses certain other kinds of shorthand. So this might be a little bit more clear and less like a whole bunch of lines of code just, sort of assaulting your eyes. You can see in this case we've used indentation to represent the paths instead of using dot paths. So you can see that given is part of name and family is part of name. The other thing we've done here is we've dropped the indices, the 0. And Sushi is smart enough to know that if you don't specify that, you must mean the first element. So it knows it's a multiple element thing, but it's going to be able to infer that you mean the first element, the 0th index. So you'll also see the indentation under address. It makes it much more readable. The other thing that makes it more readable is the very first line, we've aliased that long code system URL. And aliases are very handy because it makes your code more readable, makes the fish more readable. You don't have to retype it with a chance of mistake. So in this case, we've just had an alias marital for that marital status value code system, sorry. So down in the second to the last line, you see we're using that alias, okay? So it's just $marital. The $sign is a convention, it's not required, but we use it because it sort of makes those aliases pretty obvious to read. All right, so now we've kind of done an instance. Let's just make note of what we've learned. So there's aliases. We can remove the 0 part of arrays, and we can indent exactly 2 spaces to indicate path nesting. And that can go to any level. So let's do extensions. That's another thing that we often do within implementation guides. By the way, the instances could be examples, or they might be instances of other conformance resources. So, if you have a search parameter or an operation definition, those are actually instances as well. So you'd say instance of a search parameter, and you'd create your search parameter. So extensions are simple to define. This is a non-nested extension that I'm using as an example for laterality, either the left or right side of the body. And it's got a declaration, which is extension, a description, which you can read, and then it takes the value, which is part of every extension, and says that value, it's going to use a type rule to say that's only a codable concept. So that constraint, then your extension has to take a codable concept, and then you can bind the value to a specific value set, which in this case is a HL7 value set, which I think has left and right in SNOMED codes. I'm not really sure. So now you've defined an extension. So that's pretty easy. Now, how do you use the extension? How do you add it to a profile? Well, let's take a body structure resource, not a very common resource, but it exists, and just make it a lateral body structure that has this extension which specifies left or right. So again, the declaration is profile. The keyword the keyword parent, which is required, points to body structure. and it has a description like all the other examples we've seen. And then you use a new type of rule, a contains rule, which says that the extension, which is an array, the extension array contains that laterality, and that's the name of the extension that we've just used. And then it can have a local name. So it's named, we're just going to name it laterality with a lowercase l. And it has to have a cardinality. So a little bit harder to parse that rule visually, but it really only has, 2 or 3 parts that you have to remember here. And you've created an extension. And you can put this extension on at different levels because extension exists at different levels as well. So right now this is a top level extension of body structure, but it follows that you can also do paths and add extensions to paths. Okay, so we've seen one new rule type, which is contains. And I'll mention that in all of FISH, there's only like a dozen type of rules. So you've seen the majority of them already. And you can refer to a FISH-defined extension by a FISH name, okay? And if you want to use a standard extension that's built into FHIR, you just use the whole canonical URL. All right, and then to sort of round things out, we'll do a value set. So a value set, it has 3 parts again. It has a declaration, which is value set, colon. It has an ID, a title, a description. So the ID is important here because that's going to become the canonical URL of your value set. And you note that we've defined an alias for SNOMED because I don't like to type. So we're going to use SCT for SNOMED CT. And did I stop sharing? Okay. And also, if you want to follow along, there's the link that you can type in, and it'll take you to FISH Online. There's a funny rule which you won't understand. There's a uptick, a caret, copyright, and I'll explain that in a second, but that doesn't look like any path we've seen before. And then there's a list of 3 codes. And you'll note those are codings. So it has a code system, then the famous hash sign for codes, and then a code and a display text. And those put 3 values into your value set and you're done. Okay? Now, things to note about this example. The declaration is value set, and we're using keywords, ID, title, and description. And then that funny thing with the copyright, this is actually a very powerful feature. It allows you to set values in the actual structure definition, which is going to be generated. So there's some things which are not part of, like the copyright is part of the value set metadata, if you will. And so in this case, the value set copyright appears within that instance of the value set. So the caret actually escapes, it's like an escape character that allows you to write things into whatever the parent definitional object is, whether it's structure definition or code system or value set. And that allows you to do anything with FISH that you can do in any other, even if you were hand editing the structure definition. All right, so I want to leave some time for questions. You can do intentional value sets. I won't go through this, but that's a way of creating a rule which brings codes into your value set. Okay, so we've been through a lot, and I appreciate your patience. The full language reference, you can see here, it's up at the FHIR.org site. And if you just Google FHIR Shorthand IG or something like that, it'll take you there. And we also have a quick reference which has the entire syntax of the FISH language on one sheet. Thanks for that idea, FHIRly. Definitely stolen from FHIRly, but it's a good idea. So we have a cheat sheet. And This is just a summary of some of the things we've learned in terms of the common declarations and keywords. There for your reference when you get the slides. Later on, you can download the slides. These are the basic FHIR rules that we've looked at, the assignments, the binding, cardinality, flag rules, and type rules. So what did you learn? Well, I hope you've learned why you might want to learn FHIR Shorthand. There's a big community. It's very powerful. Diego came to me at lunch and told me how much it's changed his life. Richard was there and he can testify, and I was shocked, but I don't think it changed anyone's life, but it made your life easier maybe. There's 3 parts to a FHIR definition. I hope we've learned that. Several types of rules. You can create profiles and instances and extensions and value sets. We didn't do code systems. We didn't do mappings. We didn't do invariants, but you can do all those things in FHIR. And I hope you'll have fun with FHIR Online. That's an interactive playground where if you haven't typed any of those URLs in yet, you will when you stay for the next session, which I'll remind you is with Chris 10 minutes hence, or the next session begins at 2:55, so it'll give you a little bit of hands-on experience. And I think that's it. Here's my contact information. I'll be here through Thursday afternoon, so you can always flag me down. I'll be the one wearing, a mask down there that has the FHIR Shorthand logo. So if you don't know who to ask about FHIR Shorthand, you can just read the mask. Read the mask. And yeah, you can also go to chat.phir.org, and there's a shorthand channel there where you can join the channel and join the community. So questions, any questions that have come up in the chat, Ward, or live?
Thank you very much, Mark. Yeah, there's actually a lot of questions online.
Oh boy.
But Chris is already helping, tennising a lot of them away. Do any people in here have questions? Yeah, we have a question. Maybe while I'm walking there, there was a question if people, well, maybe you can get this out of the way. So you mentioned it only supports JSON. What does that mean? Doesn't it support XML or?
Well, we only generate, Sushi only generates JSON, and GoFish only consumes JSON. There's a JSON XML converter. So if you have an XML, you can go first to JSON through and I can't give you the location of that converter. I'd have to Google it myself, but some kind person, I don't know, Ward, if you know where that is, but I don't. Yeah, there's a page of all the implementation tools. So we don't totally leave XML out, but we've preferred JSON, and I think most of the community is using JSON as well. Oh. So I'm sorry, Chris just added and corrected me closer to the tooling that GoFish does support XML. So I apologize for the misinformation, but this is the age of mis and disinformation, so I apologize. Our tooling guys are always creating more stuff than I know, and that's great. Thank you, Chris. Yes.
Thanks, that was great. And yeah, super exciting, congratulations. 2 questions. So we started off by creating a profile and then creating an instance of a resource. Can you apply the profile to the instance of the resource that you're creating?
Yeah, I didn't do that for sort of modularity of examples, but yeah, you can create an instance of a profile. And what you'll get is enforcement of all the profile's rules on the instance. So when you run Sushi, it'll tell you if that's a conformant instance to that profile. And you'll also, Chris, you inherit some things down to the instance from the profile if your parent instant of is a profile. Required fixed values will be set for you, so you don't have to reiterate that within the instance.
Amazing. One more question. Can you author questionnaires using FHIR?
Yes. And there's a feature that I think is really exciting that we introduced a couple of versions back, which is rule sets. So in questionnaires, there's a lot of repetition, right? Patterns that repeat. A rule set within FHIR is like a macro. So you can, and it takes arguments. So you can say add question and then give the name of the ID of the question, and then the other parameters of the question, for example, whether it's a multiple choice or whatever. And there's examples in FHIR School of that. And you can take those rule sets and basically, or create your own rule set, if you will, and reuse that. So instead of typing like 4 or 5 different things for every question in your questionnaire, you can have a one-liner. And that's terrific. We also have those for like capability statements and other things that are extremely painful to do. And we've been talking about doing the same for test scripts and having a set of rules that, like macros, that you can just type, turn multiple lines of FHIR into one macro.
Another question from online. Are there any people who are using FHIR files beyond design time, really in runtime, or is it always compiled to JSON and then used? Or do you see it going that way maybe later?
I don't know that there are any runtime uses of FHIR Shorthand. When it comes to like sending instances across the wire, I have not seen anyone do that in FHIR, and I think that might be a bridge too far for us.
Yeah, not in the plans. Okay.
Not in the plans.
Can you talk a little about test cases, how to create test cases?
I'd love to talk a little bit more about test cases. It is a topic of active debate right now. I know our friends at Aegis have been working on some FHIR that would do FHIR rule sets to create test cases. And we're in active discussion. So I'm not ready to sort of give you, the inside or solution to that problem just yet. So come to the next Dev Days and we'll probably have that all worked out.
You want to follow?
So you was mentioning the FHIR can create a model, and so I did have like a graphic from a graphic builder tool to use that. That cannot just one encounter. Can you create a models across some timeline?
Oh, sure. So you do that through references. For example, you could have an episode of care that has several encounters that have medication prescriptions and so forth. And in FHIR, that's just that graph, that knowledge graph is constructed through references between instances. And they're nice ways to create that and visualize it. For FHIR, it's simply like you saw the one example where it was a reference to a practitioner, and that practitioner is defined also in FHIR somewhere else. And that a reference is just basically the line that connects like an episode of care to an episode, to an encounter, or an encounter to a medication that may have been prescribed during the encounter.
So we have to close, and Mark will be around, and there's next session with Chris. But maybe one final question. You're being followed online by Lloyd McKenzie, no less, and he has a question. FHIR-defined resources, are those supported by the core FHIR publishing process?
Say it again, please.
FHIR-defined resources, you mentioned that's new. Are they supported by the core publishing process?
They are not at this point supported. So, we haven't had a case of a work group coming to us and saying, I'd rather, instead of defining my, care plan resource, instead of maintaining it through spreadsheets, we'd like to maintain it in FHIR. But if you're here and within earshot, we'd certainly like to have that conversation because, we'd like to put that into practice. We do think that that's going to be a good way to actually define or maintain resources through, FHIR 4, 5, and 6. And thank you, Lloyd, for bringing that up. basically you could define a resource. Let me not say that. You can define a logical model, which is not a resource until it's adopted within FHIR by the proper governance process. So until it, it looks like a resource, it walks like a resource, but it's just a logical model until it's gone through a governance process.
It sounds like this is a matter of time only. But
we'll see.
Great. Thank you very much, Mark. And everyone who is in person here can stay here, and Chris will follow after with the Let's Build.
Thanks very much for your attention.
Thank you very much.